Oh my God.
All right, so this unit that we're going to start today is going to go, I want to say, until approximately the first or the second week in October. So that's about a 3, if you think about it, so you got the rest of this week, which is, let's call it a half of a week. Then you've got next week, which is 4 days, or 3 days, because you don't have virtual day next Friday, which you will have a video to watch on that day. And then the week after, I think, is when you're testing on it. I think, again, that is subject to change. We haven't updated that board yet because we're still in the process of figuring out all the timelines and things of that nature. We will be in the packet for sure all week. This week will be in the packet for sure. This week, Friday, so we will open it this week, Friday, there will be a video to watch over the weekend for your homework this weekend. And you need to have that video watched before you come to class on Tuesday. There is a page in the note packet that we gave you that you'll have to fill out that will tell us if you watched the video or not. Okay? So just so you know on that one. It's a short, when we do that, they're short videos. We're talking maybe at most probably 17-minute videos. So it's not like we're not going to sit there and you got to watch this hour-and-a-half-long video on logistic functions and logarithmic functions and exponential functions and all that stuff. I think it's only like 17 minutes long. So, okay. So let's jump into example number 1. So close, but yet so far away. Okay. So if I wanted to graph this function without the use of a calculator, because we don't need no stinking calculators to graph these things. Okay. So if I want to do that, and I don't remember back to when I was in Algebra 2, then we can always, at any point in time, even at the highest level of calculus, you can always make yourself a T-chart to graph a function. Okay? That works from the lowest level all the way through to the highest level. So what we do in this T-chart is we take our values of x. We pick 5 of them. I just picked 5 random ones. -2, -1, 0, +1, +2. Could have picked any numbers there that I wanted to. Okay? And I'm going to plug them in. So if I plug them in, well, this would be +2 to the -2 power. Do I like negative exponents? No. So I flip it over, and then I do the math, right? So +2 flips over to 1/2. Okay? 1/2 squared becomes 1/4. So this is the point, -2, 1/4. If I plug in -1, I get 2 to the -1 power, which would be 1/2. If I plug in 0, and you should always plug in 0, because that's your y-intercept, a crucial part to any graph when you plug in 0. If I plug in 0, I've got 2 to the 0 power, and anything to the 0 power is 1. Okay? So that gives me my y-intercept of 0, 1. If I plug in 1, then I get 2 to the first power, which is 2. If I plug in 2, I get 2 to the second power, which is 4. Then we go to the graph to graph these. -2, 1/4 is down there. -1, 1/2 is right there. 0, 1 is right there. 1, 2 is right there. 2, 4 is right there. I connect those with a nice smooth curve. and I get something that looks like that. Follow-up question to my graph. Can this function ever be equal to 0?
No.
Why not? If I'm taking a number if I'm taking a base, I don't want to say a number, if I take a base to a power, what is the only time that would be equal to 0? If the base is 0, right? Okay. And my base is not 0, so it's never going to be 0. Follow-up question to my follow-up question. Can this function ever be negative? Why not? Why not? Why not? We can cross over a horizontal asymptote. If my base is positive, right? Because my base is positive, right? If my base is positive, is there any power that I can put on a positive number and get out a negative number? No. There's always going to be a positive number, right? Okay. Right? So it's never going to be 0. It's never going to be negative. I think it worked. Okay. When we put our horizontal asymptote on our graph, we put it in as a dashed line. Now for me, that's very easy because I can do that with different color schemes going on. For you, if you put like slashes, because it's right on top of an axis already, that works too. Okay? Right? But you've got to make your horizontal asymptote be distinguished, be on the thing. Okay? All right? So my horizontal asymptote then would be the line y equals 0. Would be that horizontal asymptote. Last question for this example. Is this function an example of a growth or of a decay?
Growth.
Why growth?
Because up.
Not because of up. Because as we're going to the right, it's increasing. Okay? I could say the same thing for a decay, just up. Because a decay goes up, but a decay goes up as you're going to the left. So you have to be more specific than just up.
Got it.
Okay?
Upright.
Up and to the right. Yes, it's growing as you're going to the right. Okay? Good? What I would like you to do now is I would like you to do the next 2 examples on that page. It's got to go on the canvas. So if I plug in -2 here, that's going to be 2/3 to the -2, which is going to be 9/4. If I plug in -1 there, that's going to be 3/2. If I plug in 0, that's going to be 1. If I plug in 1, that's going to be 2/3. If I plug in 2, that's going to be 4/9. 1 and 2, 1 and 2. I gotta go up to at least 3. So 1 and 2 and 3. Okay? So then that is going to be 9/4 is 2 1/4. 3/2 is 1 1/2. 1 is 1. 2/3 is 2/3. 4/9 is 4/9. So that one looks like this. That is going to be a decay. It is going to have a y-intercept of 0, 1. It is going to have a horizontal asymptote still at y equals 0. And I need to put that on my graph also. Agree with that one? Okay. Then let's go to this one. So if I plug in -2, if I plug in -2, then that's going to be 4/25. I have to square and flip that. -1, I'm going to write 1 though as 25/25. So that's going to be -21/25 there. If I plug in -1, then 5/2 becomes 2/5 -1. Well, now I can write 1 as 5/5. That's going to be -3/5. If I plug in 0, then 5/2 to the 0 power is 1, -1 is 0. If I plug in 1, then I get 5/2 -1, but now this would be -2/2, so then that would be 3/2. If I plug in 2, I get 25/4, -1 is 4/4, which is 21/4. 0, 1, 2, 1, 2, 1 and 2 and 3 and 4 and 5 and 6. Okay. -21. Oops, I gotta go down 1. Gotta go down 1 too. -21/25 is almost -1. -3/5 is -0.6. The origin is the origin. 1, 1.5 would be here. 2, 5.25 would be there. So it would grow like this. My y-intercept would be 0, 0. This one would be a growth. And my horizontal asymptote would shift to y equals -1. I might have forgotten to circle. If I did circle the K. Okay? Got it? So, a couple of things to remember from Algebra 2, when you were in the 2s last year. Okay? So if our form of our equation is, our exponential equation is y equals a times b to the x power, if that is the form of our equation, then we are going to be an exponential growth if b is greater than 1. We are going to be an exponential decay if b is between 0 and 1. Okay? So that gives us a growth, that gives us a decay. Okay? When we graph exponential functions, we really only need minimum to graph our 2 key points and the horizontal asymptote. Okay? The easiest exponents to find, or the 2 key points that we want you to find, are when your exponent is equal to 0 and when your exponent is equal to 1. Those are the 2 key points that you need to graph. When your exponent is 0, when your exponent is 1. More than that just makes your graph more accurate. Okay? But those are the minimum. I was telling the last class that yes, you graph those, but then you should also graph one more like out a little bit farther on the taller side, where the function is bigger. So on the left, if it's a growth, on the left if it's a decay, on the right if it's a growth, just so that you can get that accurate curve going up, so that you're not just floating it out into wherever it needs to go. Okay? If we have graphs of this form, the y-intercept then is the point 0, comma A, and the horizontal asymptote is the line y equals 0. Okay? Because if we plug in 0, b to the 0 power is 1 times a is a, so that would be 0 comma a, and our horizontal asymptote is y equals 0. Now, if we get into some more complicated type exponential functions, which we will, okay, if we get into those, then what this number after the exponented term does, so this part right here, if we go back to that last example that we talked about, it was this part right there that shifted our horizontal asymptote to y equals -1. Up here, it stayed at y equals 0 because really it's like plus 0 there afterwards. That part of the function shifts your horizontal asymptote to the line y equals d. Okay? I will tell you this right now. Hear me now, and believe me when we take the test. If we ask you for the horizontal asymptote and you just give us the number, not y equals the number, you are wrong. And don't come crying to us. Okay? Asymptotes are lines, not numbers. Okay? So you need to give it in line form. Okay? What I would like you to do is I would like you to do number 1 and number 4. 1 and 4, please. Exponent in number 1 that we would need to make the, or x value, excuse me, not exponent, x value to make the exponent be 0 would be 0. X value to make it 1 would be 1. So if we plug those in, then we would get y here. 3 to the 0 power is 1. 3 to the first power is 3. So when we graph this one, we would be 1 and 2 and 3 and 4. 1, 2, 1, 2. We would for sure go through 0, comma 1, and we would go through 1, comma 3. We would go through 2, comma 9. Now I got to remember that attention to detail makes it your life be a little bit easier because the product, the quality of the homework, the test questions, what you're giving me is so much better. Okay? I could here just make this go like this. I've seen this already today. I could make this go like that. Yes, I have graphed a growth function. Okay? But is it accurate? No, it is not very accurate. So instead, I could say, all right, so I'm starting out here, starting low, it's growing, it's growing. Now, I need to be way up here. So I'm not just going to go kind of off like this. I'm going to actually keep that growing up and up and up and up. Okay? I want to be as accurate, or you should want to be as accurate as possible. Okay? All right? Then on the next one, the two values of x that are going to make my exponent be 0 and 1. Oops, got the break. I forgot to identify the horizontal asymptote, and I forgot to put it on the graph. that also. Okay. Number 4 here now, to make this exponent be 0, that would be at 1. To make the exponent be 1, that would be at 2. My y values then, if I plug in 1, I get 1 minus 1 is 0. 4/3 to the 0 power is 1, plus 2 is 3. If I plug in 2, I get 2 minus 1 is 1. 4/3 to the first power is 4/3. I need to add to that 2, but I'm going to write 2 as 6/3, and that gives me a value of 10/3 there then. One comma 3, 2 comma 10/3. I also know that my horizontal asymptote moved to positive 2. Agree? Questions, comments, concerns, clarifications? Yes, ma'am. How do I find the horizontal asymptote? So the horizontal asymptote is normally y equals 0. But if there's something added to or subtracted from after the exponented term, then that's what it is. Okay. Then we have out there this special number, and it's so special, it's a number that we gave a letter to. Okay? So it's E. It's Euler's number. Okay? It came upon in the 1600s with Napier's work on logs, as well as Bernoulli's work with continuous compounded interest. Bunch of all these different people, but Euler developed it way, way, way back ago. He found, or they found, I should say, that if you use E, 2.71828192817 something, 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 it's an irrational number. It never repeats itself. Okay? But we know some things about it. So if I wanted to graph the function y equals e to the x power, right? Or f of x equals e to the x power. Okay, what do I know about it? Growth or decay? Growth, because my base is bigger than 1. Okay, what else do I know about it? The horizontal asymptote is y equals 0. Okay, the horizontal asymptote is y equals 0. Okay. What points does it go through? Goes through the point 0, 1, and 1, e, which would be like 2.71828. Okay. So it's going to look like this. Going to have a horizontal asymptote right there. Okay. Now, you may be saying to yourself, why? Why E? Why do we need it? Well, here's why you need it. One, it's needed in when your banks need it. Okay? because your bank continuously compounds your interest. Okay? So that's off of a function based off of E. But where we need it the most is it makes our growth and decay much easier. If you remember back to y equals a times b to the x power, b was greater than 1 makes it be a growth. 0 to 1 makes it be a decay, so on and so forth. Here now, in E, a growth function is based off of this little k right there. That's what determines growth or decay. If k is positive, we are growing. Because if you think about it, E is roughly 3. We'll just call it 3 for calling it 3's sake. Okay? If k is positive, when you plug in all your numbers, x equals 1, x equals 2, x equals 3, x equals 4, those are all going to stay positive. 3 to the first is 3, 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81. Still growing, 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 growing. Okay? So k is positive, we grow. If k is negative, then we decay. Because now if you think of it, if I plug in x equals 1, that's 3 to the negative 1 power, which is 1/3. Plug in negative 2, that's 3 to the negative 2 power, that's 1/9, so on and so forth. Okay? So that's how that happens. Okay? So, the comparison betwixt the two. Okay? So for growth, B would have to be bigger than 1. For growth, K would have to be positive. Just makes it easier. It's just nicer. Okay? With decay, B is in between 0 and 1. K is less than 0. Okay? In the written word, because we like words, okay? If my exponential function is of the form f of x equals a times b to the x, then the growth rate of growth or decay is controlled by the value of b. If b is bigger than 1, it's a growth. And if b is between 0 and 1, then the function is decaying. And we're just literally saying the exact same thing once again in word form this time. If k is positive, it's a growth. If k is negative, it's a decay. Simpler, cleaner, nicer. The higher you get in mathematics, the more things will be based off of E because it's nicer. Okay? Okay? Now, really, because you know if it's a growth or decay, you really, with E functions, you only need to find that one y-intercept. Okay? So you need to plug that one in. Okay? So if I plug in a value of 0 here, 0.5 times 0 is 0. E to the 0 power is 1 times 4 is 4. So I go through the point 0, 4. Okay? That's the big one. That's the main one. We know, is this a growth or is this a decay? It's going to be a growth because my k is positive, right? Okay? All right? So then, if I plug in 1, I should get a bigger number than 4. Okay? All right? So let's take E just as 3 for right now. We're going to do this without a calculator. Okay? 0.5 times 1. 0.5. E to the 0.5 power is like the square root of E, right? Okay? So 3 is like E, let's say. What's the square root of 3, roughly? Smaller than 2, bigger than 1, right? Okay? It's actually 1.7. Okay? Right? 1.7 times 4.
6.8.
Roughly 6.8. So this is going to be approximately 6.8. Ms. Kleiber, did you actually do it? I saw you had your calculator out, so that's why I asked. Okay. I was going to see how close we were. I know we're off because E is not 3. So you would do 4 times E to the 0.5 power. There you go. See, so we're only off by like what, 0.2. Okay? Right? So it's a growth. We go through the point. Oops. This way. 0, 4. And then right away, we're here at 1, 6.5-ish is what we figured out. Horizontal asymptote is still y equals 0. Agree? Love it. Okay? Next one. What's my horizontal asymptote? Let's start by putting that on our graph. 1 is a number. Y equals 1 is our horizontal asymptote. Okay? Is this a growth or is this a decay? This is going to be a decay. Okay? Right? So let's plug in 0. Right? If I plug in 0, I get how much? 15? Everybody agree on 15? Yeah? Okay? Let's plug in what? What do you want to plug in next? 1? Okay? Let's plug in 1. If I plug in 1, I get what? Again, let's use E as 3. Make it easier on this. I'd get 3 to the negative 2 power, right? Which is 1/9 times 14. 14/9 plus 1 is going to be 23/9. Which is bigger than 2 but smaller than 3, right? Okay, so we started way up here at 15. At 1, we're way down here at 2.5-ish. So it's a steep drop off and curve. Okay? what I have for you now is I have for you a graphing worksheet that will be collected the day of the test, but because we don't know when that day of the test is, if you wanted to turn this in prior to then, like if you wanted to turn this in yet this week, you could. Okay? I'm not gonna say no.